Welcome back to part 9 of our DIY Autonomous Mobile Robot Building series. If you've missed any of parts 1 through 8, don't worry, you can find the links in the video description below or access the full playlist at the end of this video. In part 8, using Fusion 360, we started to insert some components and arrange these components so they don't interfere with each other or the body shell. In this video, part 9, we'll continue with this process and then start to build the chassis. Let's pick up from where we left off. We'll begin by duplicating the wheel spacer for the other wheel. First though, we'll need to create a copy of the servo and establish a joint between the servo horn and the center of the inner side of the left wheel. To do this, hover your cursor over the surface or plane where you want the joint, press Ctrl and select the snap joint. Adjust the joint to be 3.7mm in my case from the inner side of the wheel, allowing space for the wheel spacer. Next, hide the wheel and move the wheel spacer, including the washer type spacer. Rotate it to align correctly with the servo horn and hit OK. Since the original copy is already joined, use the Align tool from the Modify pull-down menu. Alternatively, you can create a new joint for the copied wheel spacer with the servo horn. Unhide the wheel and body shell. Select Section Analysis from the Inspect menu and choose the lateral plane. Just need to flip the viewing direction and we can confirm that the wheel spacers are in the correct positions relative to the servo horns and the inner side of the wheels. Now let's revert to the longitudinal sectional view. I downloaded a step file of this SG90 from GrabCAD. I have included a link in the description where you can access the exact same model. This 3D model didn't include a servo horn, so I downloaded another SG90 3D model and used its servo horn. The link for this other 3D model is also in the description. I've inserted the SG90 and now we'll move it to the desired position. Turn on Analysis and unhide the body shell. Align the center of the SG90 with the longitudinal sectional plane. Rotate the 3D model to the right and move the SG90 down slightly so that the servo horn doesn't protrude through the neck. If you've been following this series from the beginning, you should recognize this circuit, which was designed in part 2 and built and tested in part 3. I've uploaded a step file of this circuit in my GrabCAD account, and there's a link in the description. So let's insert the circuit or perf board into the design, move to an initial arbitrary position. We also want an Arduino Uno like this one. The Arduino Uno in my actual design is a different one to this, but this one on GrabCAD seems to be a more colorful version. Check the link in the description for this version. So we'll insert the Arduino Uno into the main design. Initially I placed the Arduino here, but as you can see, part of the Arduino is protruding through the body shell, which we don't want. I spent quite some time moving the perf board and the Arduino Uno to fit within the body shell boundaries. We also need to move the battery holder to make the switch accessible and also allow for the entire removal of the battery holder for easy battery replacement. So I decided to place the battery holder at the underside of the robot. However, we also need to ensure that the wires don't interfere with the servo motor. We also can't have the battery holder too low, otherwise its corners will protrude through the body shell. So we'll just move the battery holder up a bit, which I think I have already done in this footage. Move it a bit closer to the caster wheel. That's maybe a bit too close, so we'll move the battery holder forward a bit. Now we're back with the problem of the wires from the battery holder interfering with the servo, but we can deal with that by rotating the position of the servo body by right-clicking on the joint between the servo and the wheel, selecting Edit Joint and rotating the servo by -30 degrees. There is enough room for the two wires now, but let's unhide the body shell and do a section analysis. And zooming in, we can see that the battery holder does interfere with the servo a little. So I rotated the servo by -25 degrees this time for a bit more clearance. Okay, I've now decided on the positions for the battery holder, the high-tech HS311 servos, the caster wheel, the perf board, the SG90 and the Arduino Uno. Here's a 9V DC barrel jack I created, which fits perfectly into the DC power connector on the Arduino Uno. The step file for this DC power jack is available on my GrabCAD account. Please check the description for the link. Here I've inserted the DC barrel jack into the design. We'll align it with the DC power connector that is on the Arduino. Select Align from Modify and select the central snap point on the plane at the end of the DC barrel jack. Navigate around to the DC power connector on the Arduino and zoom inside the connector to the interface to which the end of the DC barrel jack is to come into contact. Select the central snap point on this inner plane and the DC barrel jack glides into position. And there we can see the DC barrel jack properly connected to the DC power connector of the Arduino. Unhide the body shell and perform a section analysis. We can clearly see that the wire end of the DC barrel jack penetrates through the rear of the body shell. So we'll move the Arduino forward, but we need to ensure the other end of the Arduino doesn't interfere with the SG90 servo. In this sectional view, the SG90 and the Arduino don't seem to interfere. In the 3D view, we can see that the body of the SG90 is pretty close to the IC socket of the microcontroller on the Arduino, but there is no interference. Here's the 3D model of the 9V battery with its 9V battery adapter. I created the 9V battery adapter and uploaded a step file to my GrabCAD account. Please check the description for the link. The 3D model of the battery itself was downloaded from GrabCAD and I made some color adjustments. Here I have inserted the 9V battery with the adapter attached, and we'll position it between the upper side of the battery holder and the underside of the Arduino. The next step is to ensure the battery holder is centered laterally relative to the center line. Select Measure from Inspect, measure from one side face of the battery holder to the center line, and then do the same on the other side. If there's a difference, move the holder by half that amount to center it properly. In my case, 0.75 millimeters. Once the battery holder is centered, we'll move the 9V battery to an approximate vertical position and measure again to ensure it's centered. Adjust as necessary by measuring the position relative to the center line in the same manner as for the battery holder. Now that the components are in place, we can start constructing the chassis. Create a new component and label it Inner Wall. Insert an offset construction plane by selecting Offset Plane from Construct, capturing the position and choosing the vertical plane that divides the robot's left and right sides. Enter 13.2, which will give a bit of clearance from the side of the 9V battery. Select the offset plane and create sketch. To get accurate dimensions, it's crucial to capture the exact locations of the surrounding components. You can do this by pressing P to project desired lines and shapes of neighboring components. Start by selecting part of the battery holder's outline and also part of the servo's outer profile that is angled at -25 degrees, and hit OK. Perform a section analysis along this offset plane, which is at 13.2 millimeters from the center plane. Label it Inner Wall. Now go back to the inner wall and edit the sketch. The tolerances I'm using here are somewhat arbitrary, but I've measured out 0.2 millimeters, which should allow for a smooth transitional fit between the battery holder and the inner wall edge. First, draw lines and a curve around the rear and upper sides of the battery holder, maintaining the 0.2 millimeter clearance. Next, draw a line parallel to the servo's inclination and add an arbitrary horizontal line aligned roughly with the top of the 9V battery. Now press P again to project the caster wheel's center point onto the current sketch and draw a construction line from that center point to the horizontal line. I set the vertical position of this line at 49 millimeters from the center point. Use the coincident tool to tidy up any loose ends. Press P again to project the curvature of the caster wheel's wheel guard onto the sketch. Next, sketch a circle that is determined by 2 points, one from the horizontal line and the other on the vertical construction line, with a diameter of 36 millimeters. Extend a construction line from the caster wheel's center point to an arbitrary point on the wheel guard's curve, setting the angle at 56 degrees. Now draw a vertical line of arbitrary length, making it tangent to the circle, and ensure the line's endpoint is coincident with the circle. I initially created a small circle below. Later I removed it as I didn't need it. Using the cut tool, I removed half of the large circle, which turned blue as it became unconstrained. Then I added construction lines to constrain the half circle again. Connect the lower rear portion to the curve around the caster wheel and finish the rear section by removing the small circle. I also removed another quarter of the large circle and added dimensions to ensure everything is properly constrained. Finish sketch, turn off section analysis and hide the body shell. Looking at the plane of the sketch we've just created, it is clear that the inner wall is positioned on the outer side of the wheel guard of the caster wheel. The caster wheel is designed to rotate about a vertical axis. However, that may cause the robot to veer off course when reversing, so I think it's best to restrict that movement by extending the inner wall down over the edge of the curved wheel guard. So let's edit sketch and press P to project the inner curve of the wheel guard, and then add two short line segments that extend to this inner curve. Finish sketch again, and then select the various portions of the shape of the inner wall and extrude by 3.7 millimeters, which is the thickness of the HDPE board that I will be using. Go to the top of the browser to activate the entire model, and we can see our newly formed left inner wall, which also fits nicely over the wheel guard with a little clearance. To continue, click here for part 10. If the link isn't showing, part 10 isn't quite ready. Check the description for my upload schedule.